right, ladies and gentlemen, we will go ahead and get started back up again. Patrick, are you back?
Yeah, I'm here. I'm here.
All right. The show is all yours, sir. Thank you very much.
All right. Okay. And just before I need to do a little bit of housekeeping here. Just give me one little minute, if that.
Yeah, no worries in the slightest. Do what you have to do.
All right, and then share. And yeah, let's go. Voila. Voila. So I hope you can see my screen.
Yep, you're all set.
Okay, thank you. It's bizarre. I'm not going into full slide mode with this application. Anyway, it doesn't matter. If you can see my screen, this is fine.
Yeah, no, you're perfectly good. All good there. Yeah.
Okay, perfect. All right, so let's go. Now, the second part of my presentation will be focused on the advanced routing engine for PanOS. Remember when I was talking earlier about clustering, I mentioned that the 7500, even in standalone mode, will only support the advanced routing engine. And that will be the way forward. The legacy routing engine, that's you're going to hear me talking about ARE for advanced routing engine and LRE for legacy routing engine throughout this presentation. LRE is your virtual router. This is what we have available for 15 years now. But now we changed the paradigm, and that presentation that I'm going to do today for you is about that, this new routing engine. And I joined Palo Alto Networks 5 years ago, and my first task when I joined, my director told me I want a new routing engine, and because we have so many of those requests to be more agile into our network, and I started collecting a lot of data from the field, and I came up with those four important pillars. People wanted simplified operation, and that was kind of the goal at the time. But they were very uncomfortable, I would say, or even unsatisfied with our current routing engine because of its agility was extremely limited. And for example, the filtering was not very easy. Redistribution of traffic was not easy. They were missing some parameter, or some of the redistribution or filtering process were kind of awkward at time. And also, I realized, and I'm coming from the service provider industry, and BGP is, of course, the router of choice. But over time and to recently, especially with BGP VPN, BGP has becoming the de facto routing engine, even in enterprise and data center, so pretty much everywhere. So we wanted to put some emphasis on BGP as well, and provide there way more agility, way more functions with BGP, and way more filtering capability, etc., etc. So those were basically what I proposed to my management at the time. I said, this is what I'm going to do. And we started, and it was difficult, but with 10.2, we released full parity of the advanced routing engine with the legacy routing engine. So full BGP functionality, OSPF, OSPF v3, and RIP v2 are supported with IPv4 multicast. IPv6 multicast is upcoming with the advanced routing engine, but right now it's still IPv4 multicast. And we have multiple logical router available, right? And then I added a few enhancements on top of that. So the legacy routing engine here is a single run to completion, a single loop run to completion. And that has a lot of advantage because most of the routing process needs to be finished before being interrupted. Otherwise, while they are interrupted, network event can come and basically invalidate the functions that you are doing or the update you are processing. So that's why run to completion has been, for example, within Cisco, the default for a long time. Now we wanted to have something else. Now the processing power that we have available is so fast that we can have a daemon per routing process, and that's exactly what we did. We have a daemon for BGP, we have a daemon for SPF, V3, V2, and RIP. And also for static routes, we have a daemon there to maintain. And all of those daemons maintain either, if they are linked states, an LSDB database, and if they are distance vector or BGP, then they maintain a RIP. Now, all of that is aggregated into a central daemon, which maintains the global RIP for the system. And that daemon is also responsible for pushing the update through the FIB. So the dotted line in this diagram here maintain that when you go into the data plane world, into the FIB, it's a different type of memory, right? It's also belonging to the front panel port and stuff like that. So whereas in the RIP, you can do whatever you want, the FIB is a little bit more limited. The idea here is that you have a dedicated daemon for each. So when you click enable with the advanced routing engine, you actually basically fork the process. Upon commit, of course, of the changes, the process is now enrolled into the scheduler and it's forked. Rather than before, when you click enable, what you do, you create a branch in the loop for that processing. But now it's a real daemon that is forked. So that's the main difference. So you're going to tell me immediately, hey, this is nice, but this is going to consume way more memory. And you are correct. It consumes a little bit more memory. However, the fact that you can enable and disable daemon, and not we count on the fact also that not everybody's going to enable everything. You're probably going to have BGP, maybe with OSPF, but you're not going to have BGP, OSPF, RIP, and all of that at the same time. So we count on that, and we maintain the same amount of logical router as you have as virtual router on all platforms, starting from the 400 all the way to the 7,500 or 7,000. So you should not, the same scalability is maintained. Now, like I said, no more virtual router. It's all logical router, and the implementation is such that they run in a network namespace. So this is a feature of the kernel where you can basically isolate a process, and they act like a super VRF if you want. In a VRF, a traditional VRF from the Cisco Arista standpoint, you slice a process into multiple instances of the same, or multiple thread, I would say, of the same processes that handle different VRF. But you still run in the single network namespace. For us, our implementation, each network namespace or each LR run a copy of the daemons. So each daemons are totally independent from each other. They don't see each other, which is, from a security standpoint, is important to us to have a perfect isolation between all the networking process, between all the LRs. There is no default LR, also contrary to the VR, so you have to create it yourself. And each time you create a new LR, you spawn a new network namespace. Right? You cannot spawn in the default network namespace of the kernel. The reason for that is that that's dedicated for all management. That's where all of our, management daemon, SNMP, and all of that will reside. Everything is interconnected through a virtual internet interface and virtual bridges inside the kernel. And we use tap interface, etc., to interconnect all of the network namespace so that they can talk to the default network namespace and provide all the functionality, all the SNMP, the streaming telemetry, the configuration through Panorama. All of that is done internally. Right. So the advantage of this new architecture is that you have modularity. So if you have an issue with OSPF, for example, or SPF v2, that's not going to necessarily impact BGP, because they run two different daemons. And that is one of the major advantages of this architecture. Also, it's easier to troubleshoot because you can look at each individual daemon and basically troubleshooting them there. And also because we have decided to have the separation through the network namespace, one LR is totally independent from another LR. So there's no interconnections between the two. So ROD-D, if you have done some troubleshooting or if you look at some of a syslog, ROD-D is basically the management daemon. It's the one that will provide you the SNMP, syslog, and streaming telemetry. Is the one that also will take your configuration. So ROD-D resides in the default network namespace. You cannot change that. And its north-south interface towards you will not change. So towards the syslog server or the SNMP collector, that will not change. However, its internal, its southbound has been adapted to talk to the advanced routing engine. So you maintain your SNMP trap, you maintain your syslog messages, but that was paramount to us, as you maintain that, so that, for example, just Splunk, for example, or any other process that massage your syslog messages, aggregate them, or generate tickets based on them, that's not going to have to be changed, still maintained. But we have new user interface, so you have a new set of CLI there. You have new troubleshooting command, and you have, more importantly, new configuration paradigm. And let's go over that very quickly. So in order to activate the advanced routing engine, you have to go to your general settings, click advanced routing engine. And here it's important to note a few things. At that point in time, if you have to go to 10.2.5 or 11.1.2, and with that version, you will be proposed to migrate your existing configuration. So if you already have an existing configuration, so it's not brand out of the box, then your existing configuration, we will propose to migrate it to the advanced routing engine. I'm going to do maybe a quick demo at the end of the presentation, how this process goes. It's a little bit difficult to go through slides to explain it, but essentially, it's not fully automatic, it's semi-automatic, in the sense that if there are some discrepancies between the two routing engines, especially in terms of functions and timers, and we have a color code. So once you click that, it will go VR by VR, take your existing configuration, convert it, and then if it's green, that means there's no problem. It converted it perfectly. Whenever you have applied a filter, you have a redistribution between two running. It will do that. If it's green, you can be sure it will work the same way. If it's yellow, it translated it, but it's not exactly the same. I will give you an example. For example, the default IGMP timer, for example, are different between the two. The advanced routing engine use the same timer as a Cisco, an Arista, or a Juniper, whereas the default on the legacy routing engine, they were a little bit awkward and not standard perfectly. So you will flag them and say, if you have a default profile for your IGMP timer, I have changed them for you. And then you will see orange. I refuse to translate this. I cannot. The feature is no longer supported. And once again, IGMP v1, we no longer support IGMP v1 with the advanced routing engine. It's not a good protocol, by the way. It floats for 60 seconds before it stops because it does not take into account a receiver that's unregistered to a flow. So that is not a good thing. So we decided not to stop IGMP v1. But for example, we proposed static group in place, which is pretty much kind of the same if you think about it a little bit. But the feature for static group was requested by a lot of our customer, and we agreed to remove static one, IGMP version 1. So if you have configured IGMP version 1, it will flag as orange, and basically you will have to move to IGMP v2 or v3. in this case. And then red, that's the last color code, and red is, unfortunately, you have an error. You should file a tech case and work with them on the resolution. There might be something fishy in your configuration that the migration script does not understand. And we did extensive testing on it. So if you have red, there's something that an error in your config that already exists, and you don't see it, but that's possible. So we're going to go over that a little bit later. What is supported? We support all of our Gen 3 firewall, some of the Gen 2 as well. The VM series are fully supported as well, and Prisma Access is now no longer under consideration. They have migrated to the advanced routing engine. The slide is dating a little bit. What is not supported, however, is the 800 series and the 200 and 220 series and the CN series. The reason is obvious for the CN series is they don't have a routing engine, or they have a very minimalistic one, and due to the memory constraint that you have over there, you cannot have one. But the 800 and 220 series, that is the reason there is that they use a different processor. They use an ARM or RISC processor, whereas all the other one use an Intel. And when you do networking, the DNS of the processor is extremely important in the representations of your packet in memory. So we decided not to test the 800 and 220 series. They are end of sales by now. They are still under support, but you will be limited to the legacy routing engine on those two platforms. That does not mean that our legacy routing engine is totally unsupported anymore. No, we continue to support it. We will continue to add in our Gen 4 new platform. I think there is one upcoming that will also give you the choice. Will come by default with the legacy routing engine. Still, will give you the choice to migrate if you want, but we do not force the migration. The Gen 5 platform and probably Gen 6 after that will have only the advanced routing engine forward.
Hey, Patrick, we had a pretty quick couple of people asking about the PA 1400 series.
That's the Gen 4.
Okay, so all the Gen 4s then. Okay.
Yeah, so you have a choice there. By default, your 1400 will came with the logical router, the virtual router enabled, so the legacy routing engine will be enabled on them.
Okay, Corbett and Ken, that should take care of you then. So yeah.
So what did we do? So in summary, a new modern routing engine, right? Position, I like to say, for service provider. We already saw that we don't have the flip capacity to play in that market necessarily, but we are a good neighbor now, where we were like not really, we were probably the lousy neighbor before. Now we play nice with or a service provider. We have customer that are in that market that have implemented it. And they have extensive filtering, because that's what you do when you are in the service provider market. And they were kind of happy with our solutions. Believe it or not, I had a customer that had an AS path of 120 ASs. I never saw this in my life. And he said, yeah, I can filter them, which is pretty amazing. So that was something like that. So so multiple instance for SPF v2 and SPF v3 right now. No, it is possible. It is possible, but that would be associated with a new feature. Unfortunately, that feature is too early to talk about, which would be VRF, and would be associated with L3 VPN. This is in our extended roadmap. I don't want to talk about it right away, but right now the short answer is no, and it's maybe in the future. Let's put it this way. We are working on it. Yes, and we're also working on things like OSPF v3 multiple NLRI, for example. We already support BGP multiple NLRI, which was not possible in the legacy routing engine. So, which is, I think, a very important feature if you want to reduce the amount of peering you do when you are in dual stack environment. Right, you can peer over v6 and have the IPv4 prefixes with an IPv6 next hop, and that BGP supports, and we support that, especially useful for SD-WAN when you do a lot of branches and you are in dual stack mode. So that feature is now present in the advanced routing engine. But for the multiple instances, it's in my drawer with a relatively important priority. Let's put it this way. So the goal also is to accelerate IPv6. I mentioned BGP multiple NLRI. It's already there. We're going to do probably OSPF-v3 multiple NLRI as well, or maybe ISIS. I'm still on the fence. That is also in my drawer. There's no timeline for those features. We are thinking about doing them. A lot of innovation have been gone into BGP. Less probably into the IGP, like OSPF, for example, OSPF-v3. There, pretty much there's not much things that have been changed. So, what is the global change? So, a new user interface is a totally new set of, and you will be happy because if you are like me, familiar with Arista and Juniper and Cisco, you will have access list, prefix list, and roadmap. Right. This is how you configure a network node. And if you're familiar with those devices, jumping into the firewall, the learning curve is flat. Whereas if you go with the other one, I couldn't configure it, to be honest. The first time I joined, I said, what is this? It's difficult and it's awkward sometimes. It's okay for doing simple things, but as soon as you wanted to push it, you were falling into exception, and things were not necessarily always easy. Although it was working well, but it was, I had to learn it. Let's put it this way. So here we wanted to simplify. Remember when I talked about the four pillar of this simplify operation. So we hide the complexity behind the advanced button. So in pretty much every panel of configuration, you will have this advanced button. And that's where you go from simple to complex. And that is up to you. If you wanted to, you have something a little bit more complex in your network, that's where the capability of, you can unleash that by clicking the advanced button. Profiles. The new user interface heavily rely on profiles. And the profiles are reusable across multiple LR. You define once, you use multiple, right? I work in the ISP business. You do a BGP peering, and usually it's cookie cutter for certain CE. What you apply is generally the same thing to avoid polluting your read table with unwanted stuff. Especially if the CE has forgotten and became a transit area, they forgot to filter correctly. So you have like a set of stuff that you filter right away without even asking. And when you do this, you do it generate through a roadmap. And when you apply that roadmap, you apply it for every of your customer. So same thing here. You create the profile once, and then you apply to every peer group or peers individually, depending on the granularity you want. But then you reuse them, but they also inherit. We're going to talk about inheritance of the profile in a moment. The UI is way more detailed. The other one, there's way more panels. There's around 500 new configuration panel with this new UI. And as you can see here, everything, the nice things are hiding in the filter section. You have access lists for v4, and access list for v6. Don't forget, these are control plane access lists. Do not use to filter your data plane traffic, right? We are a firewall. Prefix lists and v4 and v6. Prefix lists and access lists are mutually exclusive. So if you choose to do something simple, once again, the advanced button, right? If you do access list fixed mask, prefix list variable mask, if you do access list in a roadmap, for example, you cannot do a prefix list at the same time. It's either or. ASPath list, of course, regular, large, and extended community list filtering, roadmap for redistribution, and for BGP neighbor. So those are basically the filter profile. You have then all the global timer profile, per interface timer profile, authentication profile that are available for each protocol. That's pretty much the standard. And then you can redistribute, and that is also a profile. I'm going to go over that very quickly at the end of our presentation.